In this particular problem, we would like to solve for x. But if you look closely over here, again, in order to combine your fractions, you have to have the same denominators. So we have to determine what our LCD is. So over here in the corner, I'm going to write my LCD. Okay, we have x plus 2, we have x, and then we have x and x plus 2. So our LCD is a combination of our denominators, which is x and x plus 2. So what we're going to do is we're going to go ahead and multiply by the LCD for each one of these terms. So we're going to put x and x plus 2 in front of each one of these fractions, x and x plus 2. Our goal is to cancel out the denominators so we can solve this equation. All right, once you are done putting your LCD in front of each term or behind it, where you have room, you're going to go ahead and start canceling. So x plus 2 cancels with x plus 2. X cancels with x. X and x plus 2 cancels with x and x plus 2. Our next step is to write what we have left over. So we have x times 2, which is 2x, minus, we're going to use our parentheses because of our negative, so we have x plus 2 inside the parentheses, is equal to, since everything here canceled out, we end up with a negative 4, because that was the only thing that was not crossed out. At this point, we're going to distribute our negative, because that's like saying a negative 1 right here. So we end up with 2x minus x minus 2 is equal to negative 4. 2x minus x is 1x, or x minus 2 is equal to negative 4. Add 2 to both sides. We end up with x is equal to negative 2. Once you get your answer, you have to check that your answer is an actual solution to your problem. Because you're dealing with rational equations, this answer could be what we call an extraneous answer. So in other words, every denominator should not equal to 0. So over here, when we take our answer, if you look at the first fraction, or we could write out what are excluded values. So our excluded values for this equation, x cannot equal a negative 2, and x cannot equal to 0. Since we got an answer of a negative 2, this is what we call an extraneous solution. So therefore, this problem, even though we worked it out, has a no solution. I want to emphasize why x cannot be negative 2 and it cannot be 0, which is also known as our extraneous solutions. So if we look at the original problem, we had 2 divided by x plus 2 minus 1 divided by x is equal to negative 4 divided by x times x plus 2. So basically, what this represents is we cannot have a 0 in the denominator, because if we plug in a 0 in the denominator, for example, 2 divided by 0, if you plug that into your calculator, it will tell you an error. So this is undefined. We cannot have a 0 in the denominator. So for this particular problem, when x is equal to negative 2, if we plug it into our equation, we get negative 2 plus 2, which results in a 0 in the denominator. Here, if x is 0, that results in a 0 in the denominator. On the last part, whether I have 0 or whether I have negative 2, that will result in a 0 in the denominator. So in order for us to avoid this, we say that these are our excluded values. Therefore, if we end up with negative 2 or 0, that is our extraneous solution. So in this particular case, this problem has no solution, because the only answer we got was extraneous.